Okay, bear with me a little bit. At the end of the video after this video, I say now we're going to talk about systems of equations. And instead of doing that, you're going to see systems before the next video. Again, one of the beauties of me taping all these little segments is I sometimes shuffle the order around from what I had for the agenda here. And I wanted to do another shuffle, so. Systems of linear equations was supposed to be the last thing on this third night of class, but instead I want to sneak it in now, and then, I'm going to rework that little outline. But anyway, so no big deal. You're going to see all the material one way or the other. But here we go. I want to talk about systems of equations now, okay? Systems of linear equations. Okay, we didn't do any graphing in this course, okay? Now, and again, these are systems of linear equations of two variables. Okay, we didn't really do any equations of two variables at all yet, so let's take a minute to talk about that. We did one variable. X plus 3 equals 10, okay? We got it. How do you solve for x? You get x all by itself, and you say, bada boom, bada bing, x equals 7, I got it. Okay, well that's one variable. If I have two variables, x plus y equals 10, well now there's a little more to the story here. Because now I have two unknowns, and I have a two-part answer. My answer is going to have an x part and a y part. So if I ask myself, what's the solution to this equation? What value of x and y would make this a true statement? I'd realize that there's more than one answer, right? Because, for example, if x is 1 and y is 9, that equals 10, right? If x is 2 and y is 8, that equals 10. If x is 3 and y is 7, that equals 10. So how many answers are there here? Okay, and I might run my way all the way up to 10 and switch them around a little bit and say maybe there's 10 or 20 different possibilities here. There's actually an infinite number of possibilities, right? You got to think a little bit outside the box here. If x is 100 and y is a negative 90, right? That equals 10 when I add them together. If x is negative 1,000 and y is positive 1,010, that equals 10, right? There's an infinite number of possibilities, okay? So I'm kind of stuck here. When I have an equation with two variables, I have an infinite number of solutions, and that's okay. Each solution has two parts, an x part and a y part. Okay, and I call that an ordered pair. And I write them in parentheses, x comma y. Now this has nothing to do with that interval notation stuff we did earlier. Okay, x comma y, and anything that would be a solution to the equation, I'm going to write that way, okay? And like we said, there's an infinite number of solutions to that equation, okay? And in an algebra class, we talk about finding some of them. We just found some of them here. They're rather easy to find in this case. But then another thing we also did was graph these, okay? And we talked all about the coordinate system, and we're not going to do that here, okay? But we talked about x-axis and y-axis, and I'm not going to attempt to graph this exact equation, but we put a bunch of x comma y's on the board, a bunch of ordered pairs, a bunch of dots. And we saw that if I wasn't crooked with my drawing, that they all lined up into a nice pretty straight line. Okay, and we said that line goes to infinity there, it goes to infinity there, and every little dot I make here on the board, there's some x comma y that goes along with it, some coordinates that go with it. Every one of them, off to infinity, off to infinity. That's why we have an infinite number of points. Okay, infinite number of solutions to that equation. Okay, that's a single equation with two unknowns. It has an infinite number of solutions. Well, what systems of equations is going to do is it's going to say, okay, and when we get a little bit further into this whole business of equations, maybe this will ring a bell. Y equals mx plus b. If anybody ever remembers that little template there, that was our classic template of graphing a line. Okay, B, something we call the y-intercept, M we call the slope. I know I'm bringing back nightmares now. Okay, we're not going to do any of that here, but that was kind of the classic way to graph that line, okay? Well, and I could turn this equation up here into that just by doing a few maneuvers. Well, with a system of equations, you know, we're going to do this without graphing, but let me just throw the graph up here again. I've got two equations now. That's why it's called the system. There's two equations. Let's say one of them looks like that. Okay, there's my line. Off to infinity, off to infinity. It's got all these points on it. Every one of these points has some kind of x comma y that goes with it. And every one of those points works in that equation, whatever this equation is, right? Whatever it is, some y equals mx plus b. Okay, there's that equation. Well, now we're going to have a second equation. Brainstorm me, I bust out a different color. Good thinking. So now I got another line. Let's say the other line looks like that. It's got its own little infinity of solutions here. All these purple dots, they line up with the purple equation here. And it's got its own y equals mx plus b. Okay, so I've got two different lines on the same graph there. Two different equations. Each equation has an infinite number of solutions on their own, okay? But if I look at them together, there's one real special point on the board, on the paper there. And that's where those two lines cross. That is a special point, isn't it? Special place. Oh, come on. I can't find a third color. I'll find one. That is a special place. Right here where these two lines cross. Okay, that little spot right there is the solution to the system. The only solution to the system. It has one solution. Right where those two lines cross. That's it. Each equation by itself has an infinite number of solutions, but there's only one solution to the system. And that's what we're trying to find. Okay, it's some x comma y, right? It's an ordered pair. What is it? I want to find it. But I want to find it without graphing. Okay, we're going to look at two other ways to find it without graphing. Okay, we didn't do any graphing here, sadly, in this course. Okay, the first way is called the substitution method. Okay, so I'm going to have two equations, and here's an example. Y equals negative x minus 1 is the first equation. 4x minus 3y equals 24 is the second equation. Now, one of them is solved for y, the other one isn't solved for y, but that's okay. They're both equations that involve x and y, and that's fine, okay? What the substitution method does is it requires us to solve one of these equations for either x or y. Now, this first example, the first equation is already solved for y for us, okay? So it kind of did the legwork for us. So what we need to do, we need to say, okay, you know what? Y equals all that stuff right there, that negative x minus 1. That's y. That's what y is. So I'm going to take that information, that negative x minus 1, and I'm going to substitute it right in the other equation where I see the y, right there, because that's what y is. So now look what I'm going to do with this other equation. 4x minus 3 times y, but y I'm now going to represent as negative x minus 1 equals 24. Okay, so I took the information from one equation and I put it in the other. And look what I have left now. I have only x, one unknown. I can solve an equation with one unknown. 4x, I'm going to distribute a negative 3, that'll be plus 3x plus 3 equals 24. Combine like terms, I'm going to get 7x plus 3 equals 24. Subtract 3 from both sides. 7x equals 21. Divide by 7. I'm going to get x equals 3. Okay? Oops, there we go. I'm going to get x equals 3. Okay, now normally we circle it and we're done, but we're not done yet. because I'm looking for where they cross, and I'm not even attempting to draw these correctly, okay? It just seems like I kind of dumb lucked out of it, that kind of looks like x equals 3 there. I got lucky, okay? That's half the solution. I need an x comma y. That's my solution, x comma y. I know the x part is 3. Now I got to find the y part. And I'm going to take this 3 back to either one of my equations, whichever one looks easiest, and that top one looks easiest. So now I'm going to take the 3 up there. So negative x, so negative 3 minus 1, y equals negative 4. Okay? So 3 comma negative 4 is where they cross. Again, my graph didn't even attempt to be accurate. It's not. But that's where those two lines cross, at 3 comma negative 4. All right, and we're going to find it just like I did there. We're going to substitute the information from one equation into another, and then we have an equation that only has one variable at that point. Okay, solve that equation to find the answer to that variable, and then we're going to use that information to find the other one. I'm just thumbing through quickly through one of the practice exams. I don't see a problem like this on the practice exam, but it was in the study guide, so it's beneficial that we spend a few minutes on it here anyway. Okay, so that's how we're going to solve that. All right, let's do another one. Substitution method. Let's do this one. Let's do one where we have to kind of make a choice here. 5x minus 4y equals 9. X minus 2y equals negative 3. Okay? Now I don't have anything nicely solved for it. You see that? The first one I had an equation nicely solved for y. This one I don't, so I have a choice to make. I've got an x and a y in the first equation, and I've got an x and a y in the second equation. I need to pick one of those 4 and solve for it, and then I'm going to use that information moving forward. Okay? I'm sorry, I'm distracted here. You can tell I'm looking at another practice exam, and there is a system of equations on there, by guy. All right. I knew I saw one. Okay. In my algebra class, I do all 4 ways. I say, let's do it all 4 ways, and let's discuss which way would be the easiest, okay? If you have a coefficient of 1, like we do there, that's the easiest, okay? If you don't, ultimately you're going to divide to solve these equations, and you may give yourself a fraction, unnecessary fraction, okay? But I guess that's life, if you give yourself a fraction. But try not to. If you pick one that has a coefficient of 1 or one that has a nice, easy divide, then you won't give yourself a fraction. So I'm going to grab the bottom equation and solve for x. I'm just going to do it right here in place. So I'm going to add 2y to both sides. So x equals 2y minus 3. Okay, I solved that bottom equation for x. Okay, all good? So now I'm substituting that information into the top equation. Whichever one I use to solve, I got to substitute it into the other one. Okay, so x is that information right there. I'm going to put it right there in place of that x. So it's 5 times x. It's 5 times 2y minus 3 in parentheses. Minus 4y equals 9. Okay. Now I only have y on the board. Okay, so let's solve here. Distribute 10y minus 15 minus 4y equals 9. Combine like terms. I'm going to get 6y minus 15 equals 9. Add 15 to both sides. 6y equals 24. Divide by 6. I'm going to get y equals 4. Again, only half the solution. I need an ordered pair x comma y where these two lines cross. I only have the y component. I got to find the x component. The easiest place for me to go to find the x component is right here where I did all this homework and I made it x equals. Okay, I know you can hear that singing in the background. Sorry, that's my daughter. That's the easiest place to go, okay? So x equals 2 times 4 minus 3, x equals 8 minus 3, x equals 5. Okay, so how I report this answer, I mean, it might ask you for it this way, x equals 5, comma, y equals 4. That might be what they're looking for. But as an ordered pair, we always write it as x comma y. So we would write that as 5 comma 4. Okay, that's how we would report that solution. Okay. All right, I like it. That's the substitution method. Okay, there's one other way to accomplish the same thing, and that's called the addition method or the elimination method. Okay, we're literally going to add the two equations together, okay, with this method. Let's just jump to it here. X plus y equals 4. X minus y equals 6. Okay? I'm literally going to add the equations together. X plus x is 2x. Y plus a negative y, gone. X 4 plus 6 is 10. Look at that. I got a real easy equation only involving x. Divide by 2, divide by 2. X equals 5. I'm already half done. I got to go find y, but I've got x. Grab either equation, doesn't much matter. Solve for y. X we now know is 5. Apply 5 plus y is 4. Subtract 5 from both sides. Y equals negative 1. Okay? 5 comma negative 1. Okay, so it looks like this method is so much easier. Man, that was fast. Well, it's not always quite so easy. Okay, and that's because I got dumb lucky here. Y plus negative y, the y's disappeared. That's not going to always happen. What about this one? 3x minus y equals 11. 2x plus 5y equals 13. If I try to add these together, nothing disappears. And we have to. That's why it's called the elimination method. I want to eliminate either x or y. It doesn't matter which one. But one of them has to disappear when I add the equations together. And you'll see that's not going to happen in this case. Okay? So now I got to perform some operations on these equations to make it work. I've got a positive 5y down here. If I had a negative 5y there, then it would cancel out, right? So I'm going to multiply my top equation by 5. I can do that with an equation as long as I do it to both sides. Okay, so I'm going to multiply by 5. So now I'm just going to write it underneath here. So this becomes a 15x minus 5y equals 55. See how I did that? Okay, not too shabby, huh? Now look what happens when I add them together. Now I get 17x, the y's disappear, equals 68. Okay? Solve for x, divide by 17, divide by 17. I get x equals 4, half the battle. Okay? Go back to either equation, makes no difference. And find y. X is a 4, so 3 times 4 minus y equals 1. So that's 12 minus y equals 1. Subtract the 12. Subtract the 12. Negative y equals negative 11. Watch out for this now. If negative y equals negative 11, that's like saying there's a negative 1 there. I got to divide by negative 1. Y equals 11. Okay, so my ordered pair 4 comma 11 would be the solution. Okay. Alrighty, all good there. Okay, I like it. Okay. I made a boo-boo. What did I do wrong? What did I do wrong? I'm looking at the book here real quick. X is 4. By the way, if you catch any other mistakes you think I'm making, oh, this is supposed to be an 11 here, not a 1. That's supposed to be an 11. An 11, an 11, an 11 minus 12 would be a negative 1, wouldn't it? So negative y equals negative 1, so y is going to be positive 1. Okay? And yeah, that's what the book says, so my bad. So 4 comma 1 is my order pair. If you think I made any other mistakes anywhere, by all means, let me know. I'm sitting here, you can tell what I'm doing. I'm sitting here at a table just working a bunch of problems. I don't necessarily have the answers to those problems in front of me. I'm just working them on the fly here, and I'm not perfect by any means, so if I make a mistake, tell me about it, okay? Let me know. Alright, let's do quickly one more. What do we want to do? One more. Do we want to do one more? Sometimes we have to manipulate both of the equations. So this method can be tedious. 4x plus 5y equals 3. 2x minus 3y equals 7. I need a positive and a negative, same number here somewhere. I can get away with just changing one of these, can't I? It's going to say sometimes you got to change both equations around. In this case, we'll get away without changing them both. I guess that's okay. I don't think they would throw a rocket science one at you. Let's just do this one. Sometimes I have to multiply both equations so to get something to drop out. So I'm going to multiply this bottom equation by negative 2. Why did I choose negative 2? Because I want a negative 4x there so I can add it with that positive 4x that's staring me in the face here. Plus 6y equals negative 14. So I'm just going to grab that top equation and drag it on down here so I can see it. Okay, add the equations together, the x's drop out. I get 11y equals negative 11. Divide by 11, divide by 11. Y equals negative 1, that's half my answer. Grab either equation. Okay, put that negative 1 in there. 4x minus 5 equals 3. Add the 5. 4x equals 8. X equals 2. 2 comma negative 1 is where those two lines cross. We found it without graphing. We found it by the elimination method, also known as the addition method, and then we previously found it by the substitution method. Systems of linear equations. 2 equations, 2 unknowns. I have to solve them simultaneously in order to find the unique solution where those lines cross. Okay, good deal. Next, so now for real on the next video, we'll pick up on some more geometry stuff.